Hello, good evening, everyone.
Good evening, sir.
How are
Good
you all?
evening, sir.
Good evening. How are you all?
Yeah, doing well, sir.
Good, good. So, what was the last topic? And do you guys have any questions or doubts in our last session? Okay, no answer mean I'm considering there are no doubts and we can proceed to the next topic. Okay, let me share my screen. So yesterday we were discussing about the Proteus software and we created one circuit where we tried to connect multiple LEDs in series. And then I asked you to create one circuit where you have to connect LEDs in parallel, right? And also I told you when we have a voltage source like 5 volt or 12 volt, how to connect the LEDs in series of parallel connection. Other than that, I gave you one small assignment where you have to find out like how many LEDs we can connect in parallel if we have a source of 5 volt. If we have a source of 5 volt, how many LEDs we can connect in parallel. So this was the assignment which I asked you yesterday. So guys, have you completed? Do you have any questions or doubt in that?
Sir,
I
I
tried
tried
this.
it. Okay. Let you complete first.
Who is completing?
Connected. I'm connected 100 LEDs in parallel, but it will not glow with 5 volt. It will glow with 12 volts.
You connected 100 LEDs in parallel and it was not working,
Yes,
but when you connected the source of 12 volt, it was connecting. So you mean to say that if we connect the source of 12 volt, we can connect 100 LEDs in parallel?
Yes.
Okay. When you connected the
Yes,
source
sir.
of
It
5
will not
volt,
work with.
when
Yes,
you
sir. I will
connected,
connect it with 5. Yes,
Mhm.
sir. But it will not work.
Okay, but I'm asking, if you connect the source of 5 volt with 100 LEDs, is it like that not even a single LED is working?
Yes, sir. And no LEDs are glowing.
How is that possible? Okay, anyone else who have tried it? Because someone was saying something in between.
Sir, I tried with 105 LED. All are working with 5 volt,
You tried
and
with
I'm
one.
unable to find the answer.
You are not able to find the answer.
Yeah, like
Okay,
exact number,
exact number.
how much
Okay,
it can glow.
okay, fine. And earlier, who was saying that he connected 100 LEDs with 5 volt source and it was not working? Might be your connections, but not okay. Okay, let me tell you guys. See,
But sir, but sir, it will work with 12 volt, not 5 volt.
you work with 12 volt, but not 5 volt.
Yes.
See, guys, when we have to find out how many LEDs we can connect in parallel, there is no limit. Okay, there is no limit. If we talk about the voltage source of 5 volt or 12 volt, it doesn't matter because we know whenever we connect the components in parallel, the voltage remains same for all the components. What is going to change is only current. So it depends like which battery source you are using. If you use 5 volt 1 ampere, and suppose if your one LED is consuming, let's take an example that you have a battery source of 5 volt 1 ampere and one LED is consuming 100 milliampere. Can you guys answer me how many LEDs I can connect in parallel? Because when we
So
connect,
can you repeat it?
yeah, sure. I'm repeating my question. We have a battery source of 5 volt 1 ampere and one LED is consuming 100 milliamperes. And now we are connecting those in parallel. So how many LEDs we can connect so that all should turn on? It's simple calculation.
10 LEDs.
10 sir.
10 LEDs, right? Because why 10? Because if we connect 10 LEDs, 10 multiplied by 100 milliampere is equals to 1000 milliampere equals to 1 ampere. So our source is of 5 volt 1 ampere and it's consuming all the current. So as we discussed, the current divides in parallel. So there is no limit until and unless we do not know about the current ratings as well. So it's up to you. Like if you want to connect 12 LEDs, you have to increase the current rating of your battery source. Is it clear to you all?
Yes, sir. Now
Okay.
it's clear.
Okay, I'll move to the next one. Before that, I have another question as well. Suppose again we have a battery source of 5 volt 1 ampere and one LED is consuming 100 milliamperes. Accordingly, we can connect 10 LEDs in parallel. If we do so, all LEDs will work. But what if I connect 12 LEDs? Will it work?
Maybe no, just because current is not going to the last LED.
So like which LED is not going to work? The whole circuit or
11th
the
and
11th or
11th
12th LED?
11, 12th.
11, 12. Why 10 LEDs are working absolutely fine?
Like 10 LED are getting value of current, but 11, 12th has no current value.
But how battery knows that how much current it has to supply to one LED?
Like first 10th consume all the currents, so there are no though there is no value for 11th and 12th.
Right. You are correct.
Am I right?
Yeah, you are right. But sometime it may also happen because we have connected 12 LEDs and current divide equally in parallel. So it's not very sure that always it will divide 100 milliampere to each LED. It may be possible it will divide 90 milliampere to each to all 12 LEDs. And so that all 12 LEDs are working but lower intensity with lower intensity. Got it?
Yeah, it will decrease its efficiency, na?
Yeah, it will decrease the efficiency. If we want the output with 100% efficiency, then maximum we should connect only 10 LEDs. And these 10
Yeah,
LEDs,
yeah.
I'm telling you because we already took the example that one LED is consuming 100 milliampere. Actually, it does not consume this much. We just took an example to understand this. Okay, now we can easily move to the next topic, that is 7-segment displays. As I said in the last session, that first we will try to complete all the simulations which we have, not all actually. First, we will try to complete as maximum as possible simulation circuits in Proteus so that whenever we move to the programming part, that time we not need to learn these simulations again because it's very difficult to understand both the things simultaneously. Suppose I'm telling you the topic about LED interfacing. That time we have to understand how LED works, how positive negative works, how voltage current works, and at the same time we have to understand programming as well. Then if I'm moving you to the next topic, suppose motor interfacing. So that time we need to understand the concept of motor clockwise, anti-clockwise, motor potential difference, motor operating voltage, motor 100% efficiency, and at the same time we need to understand about programming as well. So it's going to be very difficult for us to understand everything together. So what we can do, we can start with just simulation circuits. So first we will try to complete all the simulations, and once we are done with these simulations, we will move to the programming part. So one by one, we will learn both the things so that it will be easier for us to understand both the things together. Now, I'm going to take another topic, that is 7-segment display. Do you have any question, Yogi?
No, sir.
Actually, you were marking on the screen. That's why I asked. Okay. So we have 7-segment display, and when we talk about 7-segment display, we have two types of 7-segment display. The one is common cathode and other one is common. Anode. Common cathode display. In case of common cathode display, the common pin is cathode. Cathode means negative. That means we need to connect the negative pin with ground. And in case of common anode, the common pin is positive. That means we need to connect that pin with power or logic 1. So we can use this 7-segment display for alphanumeric. We have seen a lot of applications like in digital clocks, calculators. You must have seen the clocks in railway stations. Those are the best example to understand this 7-segment display. In 7-segment display, total we have 7 segments. Each segment has one LED on its background. Each segment has one LED on its background. So we need to create a pattern. Suppose if we want to print one. So what I am doing, first let me take one 7-segment common cathode red color display. So here we have 7-segment display. 1, 2, 3, 4, 5, 6, and 7. And on the left side, we have total 7 segments: A, B, C, D, E, F, and G. And this one is common pin, which is called cathode pin. As I said, we need to connect the common pin with ground, right? And here we have the input pins for all the segments starting from A, B. I'm putting my cursor on those segments. The name is mentioned like this: A, B, C, D, E, F, and G, right? And here from top to bottom, A to G. So suppose if we have to print one, we know we have to turn on these two segments, B and C. So this way we have to make multiple combinations to print any other number. For example, if we have to print 3, for 3 we need this one, this one, this one, this one, and this one. And technically A, B, C, D. E is not required, F is not required, and then G. So let's try this one. So what I'm doing, I'm taking a battery source. Okay, so pick BATTERY battery, and I'm making this battery to 5-volt source because 7-segment need only 5-volt of source. 12-volt is not required. Also, I told you yesterday, maximum time we will try to use 5-volt source because in future we have to learn, we have to study about microcontrollers, which generally provides 5-volt operating, which generally provides 5-volt of DC. So this is the positive terminal which I am connecting with all the segments. A, I'm shorting all the segments with the same source, and we are doing parallel connections. A, B, C, D, E, F, and G. Now, if I go to play, I can see it's printing 8. But if we have to print any other numbers like 1 or 2 or 3, then we need to make different combinations. So it's not feasible for us to create wires, to create connections every time. Right now, I shorted all the pins with the positive source. That's why it can only print 8. We cannot print any other number right now. But for that, we need to delete these wires, and let's take button. So the keyword for button is simply button, and it's called SPST, means single pole, single terminal. Push button. Push button mean when you push, it gives you the logic. When you don't push, it does not give you the logic. And it is also known as a direct switch. That means till the time you hold this, it will give you output. As soon as you release it, it's not going to give the output. If you want to make it the toggle one, the toggle is like when you press your button from this arrow, it is toggle because it holds the value. You can see my hands. I'm not holding the button, but button holding it by itself because we made it toggle. And if we tap the button from this position, it's direct one. I need to hold the left click. If I release the left click, it come back to the initial position. So this is called direct switch. Now, how many switches I dropped here? 1, 2, 3, 4, 5, 6, 7. So let's connect all of them with A to G. Considering the first switch as A, second switch as B, the third one as C, until F, so on. So B, E, F, and G. Now I'm connecting the power source with all the buttons, so we can short all of them together. So all the connections are done. Now, first let's see how these segments are working. So I'm tapping all the buttons one by one, A, B, C, D, E, F, and G. But if I hold the buttons from this position, it's going to hold. So let's print 1, B and C are required for this. Let's print 2, A is required, B is required, but C is not required, D is required, but E is also required, but F is not required, and then finally G is required. So this way, we made the combination 2. In the same way, we can print all other numbers like 0 to 9. Also, we can mention that this button is for A. What we have to do or how we have to do this, we have a tool here called 2D graphics text mode. Just select that and write A here. This one is B, then C, then D. In the same way, you can write for others as well. Okay. Now, you can see here, it's showing C and E. C mean create, E mean edit. And earlier it was showing P and L. P mean pick from libraries and L mean library manager. So now we can't see the P and L, and I want to pick any other component. Suppose I'm deleting these things. I want to delete these things, but even it's not working. As soon as I click on the window to select the components, it's showing me this window. This window is for typing one, the editing one, right? So because P and L is not there, because your cursor changed to the components graphics mode, now it's not allowing you to edit any other component or to pick any other component. So you can do what? You have to simply click P from the keyboard. If you click P from your keyboard, your panel will reset or restore to default P and L, pick from libraries. Now I can simply delete these components. I am deleting the battery as well. This time we will try to keep something else. If you need a power source without battery, click anywhere on your screen, click anywhere on your screen, click right. Then here we have place, terminal, and power. Again, right click, place, terminal, and ground. So let's connect the ground here. And again, I'm not connecting these powers directly to the pins of 7 segment. Why? Because then we need, then we can only print 8 and we have to make multiple combinations. So we can take buttons again, right? So this is same as last. It's just we change the battery source, right? You can do it by yourself very simply. I'm giving you example with only one button. Okay. You can connect all the buttons in the same way. So if I click play and if I tap this button, I can see the segment A is working. And we can also replace this power and these buttons with another component of your Proteus that is called logic toggle. So now again, see one more thing. When we clicked on this, right click, place, terminal, and power. Now again we can see the L is not here. The L is missing from the panel. L was library manager. So you can't see which components you picked for this simulation because it is changed to terminals mode. Earlier it was P and L, now it is P and T. Pick from libraries and terminal. So now it's entered to terminal mode. So the same way is, again, you have to click P from your keyboard. If you click P from here, you won't be having any option to search any keyword for your components. If you want to pick any component, and if you click P, you don't have any option to search the keyword. So what exactly you have to do again? Again, you have to click P from the keyboard, and your panel is again restored to default. And the default was PNL, pick from libraries, L library manager. Now I'm picking another component called logic toggle. We are not required to connect any source with it because it already has a power. So let's delete the power one. On other terminal where it's common cathode, I connected the ground one. So I'll complete it. I'm taking 7 logic toggles. The benefit is if we use logic toggles, that means we are not required to use the power symbol. And also it will display the value when the button is on and when the button is off. So it will toggle the logic, and the logics are 1 and 0. So if you tap, it will show you 1. If you don't tap, it will show you 0. So 0 is the initial condition and 1 is the final condition. So let's see how it's going to work. And this is also same like your button. It will also work in 2 modes, the direct mode and the toggle mode. So currently, if we tap the button, if we tap this logic toggle from center, it will show you logic 1, but we need to hold it as it's working like direct 1. If we want to make it toggle, we have to tap it from the right side arrow. So it's now BNC high and printing 1. Let's try for 7. For 7, this is very simple, ABC. Let's try for 6. For 6, it must be BC, D, E, F, and G, but the B is not required. So this is your 6. So this way we can use the logic toggle as well. So guys, tell me, do you have any questions or doubt related to this topic? Because I'm done with this 7 segment common cathode displays. Do you guys do practice after the session?
Yes, sir.
Okay, and don't you think
Yes, sir.
very good. Don't you think that sometimes you may require to recall the concepts because it's impossible? Like if we are doing these things in physical mode, we can ask many questions multiple times. But in live mode, only I'm speaking, you are monitoring, and
Excuse me, sir.
after 40 minutes, you have to implement each and everything. Sometime it may happen that you forgot what I did. So don't you think you guys need the recording of these sessions?
Yes, sir.
You sure? Because I am asking, that's why you are saying this.
No, sir.
Okay, no worries. What I'll do, I'll ask my team member to
Sir,
share. Mhm.
Excuse me, sir.
Yes, please.
Sir, I want you to recall the how to recover the default settings for the list of our components that we are
Right.
selected.
You simply need to click P from your keyboard. That there is a P button on your keyboard. You have to tap that. It will restore
Yes,
the
sir.
settings. Okay.
Okay, sir. Thanks.
Yeah. So what I'll do tomorrow tomorrow morning, I'll ask my team member, like who will be in touch with you by WhatsApp. She will share the steps to check the recordings of all the sessions which we are doing here. Okay. So by
Okay, sir.
if I forgot to share, you please remind me tomorrow morning in the group. Okay, so that I
Okay,
can see and
sir.
ask my team member.
Okay, sir. Okay.
Okay,
Okay,
but
sir.
it does not mean that if you are getting the recordings, you are not attending the live classes.
Okay,
Because
sir.
I would like to tell you one more thing here. It's impossible for me to share the recording every day. Sometime it may happen I forgot to upload the recording and then you are not able to watch that. And next day when I'm taking another topic, you are thinking what is this? What happened in the last class? So you have to attend each and every class. It may happen with me because I'm so busy in daytime because I have offline classes as well. So it wouldn't be possible for me to upload each and every day. But yes, by the end of the week, I'll upload all the recordings together.
Okay, sir.
Okay, that's good.
Okay.
Now we are changing the topic to 7-segment common anode. I'm not taking much time for that. You have to do that by yourself. Okay, you have to explore it, but I'm giving you basics of that common anode. I'm picking one common anode display. Again, we have same A, B, C, D, E, F, and G. And here again, we have same A to G. Now, let's connect A, B, C, D, E, and F. And this is not going to connect with ground now. Why? Because this is common anode. And in case of anode, the common pin is positive, which must be connected with power. That means logic 1. So now I'm going to connect the power here. How to pick power? Right click anywhere on your screen, place terminal power. And the second option is here we have the icon for terminals mode. So simply select terminals mode, select power, and let's drop it. So this time, here we have the power one. That means if we want to turn on the segment, any segment, we need to give the logic 0. So this time logic 0 is to on and logic 1 is to off. Last time, in case of common cathode, when common pin was ground, that time we connected the common with ground. So one logic was required to turn on the segments and 0 was required to turn off. But now it's just opposite. We need to create the potential difference. So this side, it must be 0 to turn on and 1 to turn off. I hope it is clear. You can try it by yourself. I'm coming back to the next. Next is 14 segment display. 14 sag is the keyword. And here we have common cathode red. Here we have common cathode red again. So I picked this one. Okay, it's very simple. See, it's common cathode. That means common pin must be ground. So let's connect both the pins to ground. These two are common pins. And then here we have the segments. Now, how to identify which segment is A? If we have 14 segment, it must be A, B, C, D, E, F, G, H, I, J, K, L, M, N. So A to N, total we have 14 segments. There are a lot of alphabets which we cannot print on 7-segment display. That is why we are using this 14-segment display. So here we can print all the alphabets like X, Y, Z, M, N. All the alphabets can be printed easily here in this 14-segment display. So how do I identify which segment is A and which pin is A? It's very simple. You have to just put your cursor here and then notice here what it's showing. I understand while I'm sharing my screen, it's showing very small. You cannot even read it properly. But whenever you will be doing on your screen, you have to put your cursor on that pin and it will show you the name of pin. Right now, if you see, I'm putting my cursor, see here, okay? You have to look here. When I put my cursor on the pin, you have to look here. So when I put my cursor, it's showing pin A. This is pin B. So it must be pin G. No, it's F. And then here it is G, H, and last must be N. Very simple. Now let's connect logic toggle. I'm not connecting to each and everyone. I'm just showing you which segment is A here. Now we understood this pin is A. So let's play. So this one is A. In the same way, it was in 7-segment. Again, same here, A. Then it must be B. Let's see. Is it B? If it's A, it must be B, but possibly it may also be B. So let's see how to check it. Connecting this with B. So this one is B. Now we understood. If it is A, if it is B, then it must be C, D, E, F. So till F, we understood. Now we have to understood which one is G and which one is H, right? So let's delete this logic toggle and connect it with this pin, which is G pin. So which one is the G segment? This one is the G segment. Now again, we have doubt the H is the right one or the left one. If clockwise we go, then it is H. If it goes anti-clockwise, then it is H. So how do I identify? Simply connect the logic toggle to the next one, the H one. So let's click play. Okay, fine. So this is H. So G, H, I, J, K, L, M, and N. Now I'm giving you assignment. I told you about these. So you have to use 7-segment common cathode, not 7-segment. I'm so sorry. You have to use 14-segment common cathode display to print M. To print M. M for mango. Okay. You have to print this. Now I'm trying with common anode display, or let's not understand common anode display because that is your assignment again. So 16-segment this time I am doing the same common cathode red, and I'll not take much time for this as well. Again, we have these two common pins. That means it must connect with ground. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. So till P, we have 16-segment displays. If you compare 14-segment and 16-segment, it is almost same, but this segment is divided into two. Here it is only one segment on top, one segment on bottom, but here it is divided into two. Here it is also divided into two. That means two segments are increasing. So 14 plus 2, it's 16 segment. So these two are common pins. In case of common cathode, we need to connect these pins with ground. If I see this one is A, this one is B, this one is which one? H. Then I, J, K, L, M, N, O, P. And here we can start from this one. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. So this is called 16-segment common cathode display. You have to try this by yourself, but now you have to take two different displays. The one is 14-segment common cathode and other one is 16-segment common anode. So with 14-segment display, you have to print M, and with 16-segment display, you have to print N. For 14-segment, it must be common cathode. For 16-segment, it must be common anode. Okay, let's finally come back to 7-segment display. The last topic for the day. You noticed this, that if we use 7-segment display, we have to use total seven logic toggles. Now let's say I am connecting this with any other controller. Right now, these are connected with logic toggles, but when we have to program it to print the numbers automatically, we have to connect this with microcontroller. So to print any number on 7-segment display or to connect this 7-segment display with microcontroller, it is very sure that we need to connect total 7 pins of the controller. So if we are doing only 7-segment interfacing with controller, that's fine. But suppose if we are making a project where we have to connect 7-segment display, LEDs, sensors, motors, LCDs, keypad, and everything together, then we have to think about the number of pins available in microcontroller. So it may be possible we have only 4 pins. It may be possible we have only 10 pins. It may be possible we have only 20 pins. So it depends upon the selection of your controller. So we have to work on this thing as well. Try to minimize the number of pins used by you. If we have to make a project, we may need many pins to connect. So when we connect this 7-segment displays, at least 7 pins are required. So if our controller has only 14 pins, that means 7 pins are required for 7 segments, and remaining 7 we can connect with other components. And if it is not possible to connect all the components with remaining 7 pins, we need to change the controller from 14 pins to 20th pin. 20 pins. That means we have to purchase big controller, which will increase the cost as well as the size of your circuit. So that time I suggest to use the IC. We have one IC which is called 4511. Okay. So I'm using this. It is called BCD to 7-segment display. Output side, we have total 7 pins, which we can connect to the 7-segment display. BCD mean binary coded decimal. So whatever data we have to give, that we will be giving using ABCD, 8421 logic. So input side, we have only 4 pins. You can see A, B, C, D. Output side, we have total 8 pins, QA to QG. So I connected the QA to QG with 7-segment display. On input side, I will be giving only 4 pins now. So from now onwards, you have to think this logic toggle as the pin of microcontroller. Okay. So now I'm connecting 4 logic toggles here, and I'm considering these are 4 pins of my microcontroller. Let's connect them with A. Let's connect them with A, B, C, and D. Now, to energize this IC 4511, we need to connect the LT LEM test pin with power. This is LT mean LEM test pin should be connected with power. To connect the logic of 4 pin, the BCD, to 7-segment pin, because in input side, we are giving the logic of only 4 pins and it's converting that into 7 pins. We need to connect this BI pin with power. BI is called bit inverse. It will convert your logic of 4 pin to 7 pins. Now, whatever logic you converted from 4 pin to 7 pin, we need a data bus so that the logic can travel from ABCD to A to G. So we must give the power to this latch enable pin. This is called latch enable, which will create the data bus. But as we see, this latch enable pin has a bar. That means it is active low pin. So if you give the logic 1 to it, it will become 0 and it's not going to create the data bus. So this time we must give it a 0 logic so that it can pass the logic 1. As it is active low pin, if we give 0, it will become 1. If we give 1, it will become 0. So that is why I'm giving 0. That's it for this IC. I reduced the number of pins from 7 to only 4. And now, as you can see, we are giving the logic 0, 0, 0, 0, and it's printing 0. I'm changing it to 0, 0, 0, 1. This D, C, B, A. D is 8, C is 4, B is 2, and A is 1. I think everyone knows about the logic of 8421. If you don't have any idea about it, you can simply check the digital electronics. Otherwise, you can ask me tomorrow. Okay. So if I have to print 2, 0, 0, 1, 0, 3, 0, 0, 1, 1, 4, 0, 1, 0, 0, and 5, 0, 1, 0, 1, and 6, 0, 1, 1, 0, and 7, 0, 1, 1, 1, and 8 is 1, 0, 0, 0. So that's it for the day, guys. 1001 is 9. You can try it by yourself. Complete your assignments of 14-segment common cathode for M, for 16-segment common anode for N, and also try to use this 4511. See you tomorrow. If you have any questions or doubts, you can let me know by WhatsApp. Okay?
Okay, sir.
Okay, guys. Good night. Bye-bye. Take care.
So,
Good night,
Thank you, sir.
sir.
Have a good night.
good night.